Good morning, everybody. First of all, I extend our sincere thanks to the organizing committee of International Symposium on Recent Advances in Self-Assembled Materials and Supramolecular Chemistry for giving us the opportunity to present our work in this well-organized symposium. I'm going to present our work on photo-induced performance of hydrothermally developed natural dye-anchored titanium nanoparticles, a new strategy to enhance SPF factor. My presentation will be based on following contents. Nanomaterials are amazing materials, proper use of which can revolutionize the future technology. Presently, there is a strong thrust among the scientists throughout the world to explore the promising applications of nanomaterials in various fields. This effort is involved in two factors. Number one, emerging novel properties of the materials in nano domain. And secondly, the world range potential applications based on the nanomaterials provides an important driving force to push the size of the material in the nano domain. The excellent UV absorption property is one of the most attractive property of the nanomaterials, which make it a potential candidate for different solar applications using UV absorber. Though solar radiation is one of the most precious gifts for the earth, which is essential for the creation and survival of life on our earth. But the UV range of solar radiation is significantly harmful for human beings. The UV light absorption behavior of oxide semiconductors like titanium dioxide, zinc oxide endorses their use as a good UV filter for sunscreen. In recent years, these nanoparticles are getting potential attraction in the field of cosmetic applications due to good transparency in the nano domain. Titanium dioxide as well as zinc oxide are well-known UV absorbers in the bulk as well as in the nano form. But in the nano range, it retains its UV absorption efficiency in spite of being very good transparent material. This one is the one of the most attracting, promising application of this nanoparticle in the field of sunscreen. The question is that why a sunscreen? So too much exposure to the solar radiation causes premature skin aging, sunburning, skin cancer, cataracts, and many other issues. So sunscreens are designed in such a way to protect the human beings by preventing UV rays from reaching our skin. Here we have showed that in the table that the contribution of different UV radiations of solar spectrum, UVA, UVB, UVC, visible and IR, and their respective effect on the human skin. In the present work, the UV absorbent performance of peptides and hydrothermally developed nanosized TiO2 was evaluated through UV visible spectroscopy analysis. In order to increase the UV absorption efficiency of the developed TiO2 nanomaterial, a new strategy was attempted by anchoring its absorption efficiency through the anchoring a natural dye on its surface. Anchoring of the natural dye on the titanium surface significantly enhances its UV absorption efficiency. This one is the flow chart for the development of the hydrothermally developed TiO2. For this development, first of all, titanium hydroperoxide was taken in the solvent 1-propanol. It was functionalized with the very well-known functionalizing agent or stabilizing agent, that is acetyl acetone, and it was hydrolyzed by dropwise addition of water. The obtained precipitate was filtered and it was peptized with the addition of sufficient amount of nitric acid. After a few hours, the peptized TiO2 was adjusted to pH 7 and it was filtered using filtered paper for repeated, and it was washed for repeated time to remove all the nitrate groups from the solution. It was again adjusted to the pH 11 and it was hydrothermally treated at 25 degrees centigrade, and finally the hydrothermally treated titanium dioxide powder was obtained. The spectral analysis through UV visible spectroscopic analysis shows the hypsochromine shifting of absorption maxima, which confirms the formation of smaller size particles on peptidization and hydrothermally treated particles compared to that of unpeptized one. The energy band gap calculated from UV visible spectra are presented in the table as below, which shows the band gap of the developed materials at different absorption maxima. The structural analysis of the developed particles was done by X-ray diffraction study, which shows the well-known diffraction peaks at 25.3, 38.1, and 48.2, corresponding to the 101, 004, and 200 Miller planes. The hydrothermally treated TiO2 shows significantly enhanced crystallization of nanoparticles. The table shows the crystallite size of the obtained particles after peptidization and hydrothermal treatment. Coming to the microstructural analysis, scanning electron microscopic images show nearly spherical shape for all the particles through their average sizes, with different, though the sizes were a little bit different from the X-ray diffraction data. And finally, this is the figure which shows the interaction of the dye with the developed TiO2 powder. The most interesting observation was in the UV range, both type of particles show good UV absorbance enhancement on attachment of the dye. This observation was quite different from TiO2 dye interaction available in the literature. Most of the dyes undergo degradation under UV irradiation in presence of TiO2. But maybe here the charge-particle interaction between the dye and TiO2 is responsible for this type of enhancement in the present work. So finally, we have in this work, we have presented the development of surface functionalized TiO2 by peptidization and hydrothermal method. The hydrothermally developed particles shows very well crystallinity compared to the peptized or unpeptized one. The spectral analysis confirms the formation of very small size nanoparticles on peptidization and hydrothermal treatment. The peptidization and hydrothermally developed TiO2 and complexation with dye shows significantly enhanced absorption of UV radiation in the UVB region. So results shows the development of TiO2 dye composite could be a promising material to be used as a sun protector against the most harmful UVB solar radiation in the future applications. I'll be happy to hear from the audience if having any queries. Thank you.